Okay, good morning everyone. So today we'll start our lecture number 4. I will remind you to make sure that you have a valid email registered in your file at course model. And if you have that, I think you receive, okay, this problem here on these lectures. Okay, yeah, okay, good. So, okay, so if you have a valid email already, you receive an email about what we call it a practice or a demo lab test. And this demo lab test worth 0%. And we will have it this week. So please make sure you are available at the beginning of your lab sessions. And we will reboot the machine and we'll make sure that the machine in lab test mode. So during the lab test mode, according to the email, I'm not going to repeat the email again. So you will not have access to the internet. You will have access to Java APIs, also the API for I2C, which is the Java file that is created by the author of the textbook. For the Wednesday, we have on William Small Center 105, 106, and 108. And for Thursday, we have 2 sessions that start from 4:30 to 7. Now, I would like to mention, as it's written on the email, this is only for the first 30 minutes. After that, we're running the lab as a normal. You have to submit D2. Don't leave. You have a duty and you have a deadline to submit D2. So to prepare you and to make you already familiar what we mean by the lab test and what you are expecting in terms of questions, all of this, you can see this during these 30 minutes, okay? Now, the first lab test will be not this week, next week, which is February 5. And again, only students who are officially registered on this sections can write the exam. Only the students who register on the lab section 1, 2, and 3 can write on Wednesday, and Thursday only the students register in 4 and 5 can write on Thursday. It's 90 minutes, okay? And you will receive more detailed emails about the type of questions and what kind of materials. And still we have one more lectures on next Monday. We're going to go over some review questions and some tips or some hints that can help you during the lab test. Write this in your calendars. Make sure you are available, okay? And we have a policy. If you plan to miss the lab test, we have a policy. I don't think any one of you already have a plan to miss the lab test. So I recommend all of you, if you have something on advance, or I don't need to do the lab test, I will transfer the weight to the final, you will put yourself on unrecommended situations. So make sure you attend the lab test, because this lab test will only cover chapter 0, 1, and 2. So the topics, questions, the type of questions are straightforward. You don't need to do a lot of thinking, but lab test 2 will be more harder because we have lab chapter 0, 1, 2, 3, and 4. Final exam will be more because it's comprehensive for all the semesters. Delay all the questions. If you have any questions, delay them for the next lectures on Monday. Today we'll start our lectures. Last time we discussed the Java basic keywords and data types, identifier, data type convergence. It's very important to master these in terms of Java. Some of you, already have some experience on different programming language or maybe on Java, but it's good to remind them what is the data type and how we convert between two data types. Today we will try to see some examples about compute the area of circles apps, and we will highlight some issues about how we can create the user interface items and how we can grab the user interface item content in the models and how we can let the control communicate between the view and the model. You already experienced this on the D1, but just to highlight it and remind you about it. And also we're going to see the random color app where you have to, whenever you click the buttons, generate a random color. This is one of the exercises that is on the textbook. Then we're going to go to the object on Java. Just to remind you quickly about the identifier. Identifier is a kind of sequence of letters and underscores and dollar sign, and there is some constraint about the identifier. When you name the identifier or choose the name for the identifiers, should not begin with, must begin with the letters and underscores. And this identifier is the names that you're going to use in your program. So either you pick a name identifier for a class name or identifier for a variable name. So, and you have to make sure that Java distinguish between the lowercase and the uppercase. So even if you have the same identifier, but this is written on the lowercase and this is written on the uppercase, so both are different. Excuse me? I hope it's on. No, it's off. We change the battery for you. So. I think we have a dead battery. Now we have a new one. Okay? Good? Thank you. Now, it's good to distinguish that whenever you pick a name for identifiers in your Java code, it not conflict with the Java keywords. You cannot have identifier identical to the Java keywords. There is a name conventions, and for name convention, because readability, most of the time you're going to write the code that you're going to share with others. So it's become more meaningful and readable by others if we are following these conventions. So you pick a name for the variable name or a class or name of the method. So for example, for a constant, we have to use capitals. These are the keywords. These are reserved words on Java. So if someone decide to pick a name for a variable or a class name called final, it will conflict with the keywords, and this is not good. So you have to look at these keywords and make sure whenever you are come across picking a name for identifiers in your Java code, you will not conflict with this. For example, instance of, statics, okay, super, switch, all these are keywords from Java. We cannot use these keywords as an identifier in our Java code. The variable is, as we discussed last time, is a place on the memory. Based on the data type, you reserve how many bytes you need. Let me ask this question. If I have int data type, how many bytes I will reserve? 4 bytes. If I have long int data type, I will reserve 8. The same thing doubles and float. So each data type You define the variable. Whenever you decide I need to pick an identifier, this identifier for a variable name, I have to look at the name convention for the variable name. Then, based on the data type of that variable name, I will reserve some space on the memory. Here, for example, we have double radius and string name. So a string is a sequence of characters and is an object. Literal is a constant that appears in your Java code. And we saw last time some examples about these literal constants, and they are used most of the time to initialize the variables. Now, if you are using a decimal integers as a constant, do not use comma or a decimal point. Okay? And the default data type, most of the time you are using int or long data types. If you are using a float constant, so most of the time you are gonna use that double as a default data types. This is a primitive data types. Now, in Java.lang they provide us with what they call is a wrapping class. You have the primitive data type and you have a wrapping class for the primitive data type. Because Java is object-oriented, and later on this course, we're gonna see that we're gonna come across some collections at the end. So collections are collect some objects. So you cannot store a primitive data type in the collections. To be able to store a int data type inside the collections, you have to use what we call a wrapping class. And last time we discussed the wrapping class. Even Java Expert, they make it easy for us. There is a concept of auto-boxings and auto-unboxings about taking the primitive data type and put it inside the wrapping class automatic for us. So even this process, you're going to see it while you are doing Java code. It's, oh, I'm using a primitive data type and I was able to use the primitive data type as an object data type. This because Java Expert automate this process for you, which is taking the primitive data type, put it on the wrapping class as an object, and start working with this as an object. We're going to see some example later on, but keep this in your mind that there is a difference, and big difference, between primitive data type and object data type. And last time we discussed that int, doubles, all these with I as a small, D as a small, these are primitive data types. And string is an object data type, which is different from the primitive data type. Sometimes they call it a reference data type, object or reference data type, which is the data type used to allocate the objects. And today we're going to see some example about that. So these objects, when you define a string, you give a variable name. Actually, you're not storing the string at that location. You store a reference where the string is located, because the string is an object data type. But the situation is totally different if you are dealing with a primitive data type. When you define int with the name of the variable, actually you store the value of that variable on the memory. That way we are working with the primitive data type. But if you work with object, you're not storing the object at that location. You store an address where the object is stored in the memory. It's like a pointer. Where is the object is stored. Now, last time we covered this quickly about data type castings. So you are moving from one data type to another data type. And we say Java also give you this capability to do the casting manually. You as a Java program, you are write your program, you know what type of division. For example, I want 12 divided by 5. Now, the casting immediately affect the operand next to it, the first one to the right. So in the first statement, we have double average. This is the data type, double, and the name of the variable is the average. So in this case, I will go to the memory as a first step. I will reserve 4 bytes or 8 bytes. I'll reserve 8 bytes because this is a double data type. Then I will look at the assignment, the one on the right-hand side. I have a casting. I will affect 12 immediately. 12 will be what? Double. Then the division will be a double. So double divided by int, it will result a double. Now, in the second statement, story is different. You have parentheses. The parentheses force you to go in some kind of sequence of orders. And based on the programmer who write the second sentence, he wants us to do the division first, then cast the result of the divisions as an int and assign it to an int data type. So you're going to do 28.3 divided by 12. This is a double division. So you're going to have the int bar and the fraction bar separated by a dot, which is the decimal point. Then you're going to cast this to int. The first one will give you 2.4. The second one will give you 2. Now, just to test your knowledge, we go this example quickly, just to remind you that we have the operations. You look at the data type of the variable, and we mentioned last time that if there is any consistency between the data type, this will be a problem for us. Now, you have in the right side for the first sentence, you have the double between the parentheses. That means the manual casting decided by the Java programmers. So you have 2 plus 3 divided by 2. So you're going to affect the immediate operand next to the double. That will become 2 as a double. But the division has high priority compared to the addition. So you're going to go to the 3 divided by 2 and evaluate that first. And both operand, 3 and 2, are integer. So you're going to do the integer division. Then integer division plus 2 as a double, Java will promote the data type from int to the double. So given that the casting will affect the operand immediately next to it, right? And this will become 3, this 2.5, and this is 5.5, this will 5.5, and this will be 5. And I would like you to look at the last 3 statements, and you can see manually when I do the castings how the effect is changing the results. So the last one, it has different result compared to the one before the last. So you can see that 22 divided by 4, and when you do the casting for 4, you make 4 as a double. Then you promote the divisions to be a double divisions. Any questions about this before we proceed? Yes?
I'm confused. Why is the first one 3? Because 3 divided by 2 is 1.5, and plus 2 is 3.5. Why is it 3.0?
No. First you're going to do the division. Division is 3 divided by 2. This is an integer division. Actually, the result is 1, not 1.5. Okay? Any other question? Okay. Now I'm going to switch to Android Studio. And what I'm going to do in the Android Studio is repeated on these slides. So all the next slide is repeated in case of I was not able to access to Android Studio. So once I come back from Android Studio, we're going to go quickly about this or maybe skim these slides. Okay. So this is an app. I create this app on the, let me just, so in this app we will have, okay, let me just run the app for you. So in this app, we're gonna provide the radius for a circle, and we will calculate the area. It's very simple, basic one, just to demonstrate how we're gonna communicate with the view in case if you have a difficulty to implement the one, and how you're gonna do the calculation on the model, and then send the result back to the view. So let's say the radius is 1. You compute, you will have the result. You change the radius to 1.6, you compute the result. Now, let us see the design of this. This is the XML. So in the XML, we have text view, and we give a name, ID. It's a called title label with an ID. I hope Is the screen is okay, the size? Okay, good. And you can see that the gravity for this is a center. So you have the gravity for the constraint and you have a gravity for each individual item. So gravity means where you're gonna put the text, left, right, to the center, bottom up, bottom down, all this you're gonna. And what is the text? What's the label this text view print to the user? Is a print compute the area of a circle and the size, and then we have some constraint, and as you can see this is constraint from the top end of to the parent and also start on the top to the parent. Then we have edit text. Edit text is the way to communicate with the user. Edit text will allow the user to enter something for us. Then we can grab this using the control and send it back to the model and do the calculations. So this is called edit text, and what is the ID? ID is input radius. Now, I mentioned this on the previous lectures. ID during the one model should be unique. If you don't care about the ID, the Android Studio will care about it, so it will give you the ID, unique ID. Because once later on, when you need to access the user interface items, you're going to go to the resources.id, and this should be a unique ID. So if you care about your IDs, you try to name them in a way, give an identifier in the meaningful way so you can work with them later on. In terms of the height, it's wrap the content. And as you can see, I specify the input type. So the input type for this, it's a number or number and decimals. So it's a number in the top, and the category is double numbers. So you're gonna see some apps where you're gonna only limit an integer input. So you're not receiving, let's say, number of year 1.5 or something like that. So you need to limit that type or constrain the type of input. Now, if you look at the constraint, this is constraint from to the bottom of title label. So this, in terms of the organization, it will be in the bottom of the title. So the title first, and this is constrained on the bottom of the title. Then we have the button. And I didn't pay attention to the name or label because I have only one button in my app, so I leave it as a button. And what is the caption is written on it is compute. And if I click this, on a click, this on a click to communicate with the control whenever there's some event happen to this event, and this type of event is a clicking. So the click by the user on these buttons will go and search for a method name is called compute area. The style is bold, and as you can see, there is a hint, compute area of circle. And its constraint, the text is called compute, which is the same. I think this is repeated. And this is the one I want to highlight, is a layout constraint to the bottom of input radius. So in terms of the organization, there is a title, then there is an edit text, and there is a button in the view. Then we have the text view. The text view is about displaying the output. So I call this give an ID output result. And again, is the gravity is center, the size of the text, and is constrained to the bottom of the button. So from the button, you have below of the button, you have the text view. So if I look at the XML file, I get an idea how the user interface is organized. You have a title, you have edit text, you have the button, and then you have also text view, where is the result is displayed. Let us see back to the design. On the attributes of the buttons, we have an option on click, and we select the method called compute area. Let us see the main activity. In this main activity, I try to, as we discussed last time, we have a protected void on create, and we will give an argument as a bundle save instance state. So this will take care of creating the app for us, automatic for that. And this main activity actually extended from app compact activity, because this is the represent the lifetime of running the app. Now, where is the compute area? So whenever I click the buttons, I will go to the compute area to grab the radius and calculate the area of a circle and retain the result to the user. Now, because this will work with an event, and this event gonna happen on the view, we pass this view as an argument input to this method. Any
What would be the benefits of using GetContent embedded text versus find view by ID?
Yeah, I'm gonna come to that. So, compute area, if you want to create a method that communicate with the view and communicate with the model, you need to give the view as an input argument. The view, you name it as you want. You can change this name, the view, or whatever you like. The class called the view is responsible of creating the view of the app for you. Now, to be able to work with different methods, I don't need to repeat myself and have a duplicate code in my programming. I'll create what I call a helper methods. This method will help me to optimize the way of my code is written. So I don't need to duplicate the code. Get content of edit text is a help method that I create. Me as a Java code programmer, I always intend to reduce the duplicate. And also, sometimes you learn by examples. You look at the examples of other people, how they do it, and they say, okay, this is a better way than rewriting down, find, as you can see here, I get the content of edit text, I give the ID to this method as an argument, and then I say find view ID. The type here is a view object. I didn't specify what I'm gonna get here. I might get buttons, edit text, text view, all of these under the view superclass, which is responsible for user interface items. Then I say the view that I'm gonna get is actually edit text, because this is a method that I create. I know what I'm gonna deal with. I'm gonna go to the edit text and grab the content of edit text and then retain it to another method. I don't need to repeat myself again and again in the code. So the answer to your questions, why I get content of edit text is create a help method that I can reuse it every time and reduce the duplication of my code. Now, the view, I cast the view manually, as you can see on this line 34. I cast it to edit text. Then I ask edit text, the name, dot get text dot toString, and assign it to a string variable and return it to the user. So in this line, I simply execute find view by ID, go to the edit text, and grab the content of edit text, convert the content to the text, and return it as input string. Still, I'm working with a string. How I'm gonna represent the string as a double? I use double dot parse double and retain this as a variable radius double. Then I calculate the area. The area is pi r squared, so I multiply the radius times the radius. Okay, I can use math.power. I give the radius and then give 2 as a power, and then I multiply by math.by. By is a constant inside the math class. So I calculate the area and I store this on double data type. Now, after I calculate the area, I need to send the result back to the user interface or to the user who asked me to calculate the area. So I format the string. I use string.format. String is a class and it's over a method called format. And it allows you to format a double value or an integer value in a certain way to represent it. As you can see here, I want to represent this with 1 decimal point. So it will be rounded to 1 decimal point. In the textbook, you will see a lot of different version of a string.format. I encourage all of you to go and practice and take this version and try to print and see what is the result of each one of these statements written on the textbook. I have the output, as you can see, after I execute this statement in line 44 as a string. So I go and ask another help method that I create called SetContent of text view. So I grab the ID, resource.id, output result, and I send output as a string. I go to this method. This is the method called SetContent of text view. This is a help method. I encourage all of you, you can have develop your own style, but by creating a help method, you avoid a duplicate and focus on the computation that you are working with. So whenever you need to display something to text view, you just call this method and you give the ID of the text view that you would like to change the content, and you give the string, and this method will take care of the rest. So your method does not have many codes that related to find the ID, cast the text view, and then set the text view. Now, you can see I find the view, then I cast this view to the text view, and then I will ask text view dot set the content and new content, and this has an input argument. So in the input argument, which is the set text, I will take the input argument and assign it to the text view. Any question? It's an integer. This is how Android Studio makes sure that we have all the ID is represented as an integer. There will be, but this is not a scope of our topic here on this course. You name the ID as whatever you like, but there is a translation in the middle to the int type. So for you as a user, you name it input radius, but Android Studio will understand this. There is a transition period of hashing codes and all this. We'll transfer this to a value as an integer. So it will work with an integer easier than working with a string. But the data type, when I ask here, this r.id.input string, this is an integer data type. All this sentence, r.id.input radius, Android Studio will understand the retained data type from this statement when you execute it is an int data type. Any other questions? Yes.
Line 44 you use area, and in the PMI conflict we use index. What are they? Area.
Area?
Yes.
Area is a variable. I define it inside the method. Here, I define double area. Then I compute radius times radius times then I calculate this. It's a variable inside my method. I do the string formatting for this variable. I represent it as a string. Then I display the result to the text view. Capital is for the name of the class. With the small is the name of the variable. This is a convention that we discussed early on the slides. Whenever you define an identifier and you would like to use this identifier for a class name, you have to use a capital for the first letters, as like a title. Capitalize the first letter of each word. Okay?
You can use anything except view for the variable.
Yes, I can say view capital, view, and here I can change this to any name I would like. Any other question? Yes. R is the resources. You ask R resources.id. You go to the app here. This is the resources file, res. So you are saying, I wanted to go to the resources, go to the ID in the resources and grab this. Okay? Yes.
When it says string.format, what does the dot represent? Like, what do you mean dot format?
Dot format is you ask, I want a decimal point, 1 decimal point after the integer value. Okay? I encourage all of you regarding this one to go to the textbook. There is a lot of description about the textbook. One thing I would like to add, you can ask as many questions as you want, but if you don't practice, all these questions, all my answer worth 0 for you. Okay? Without practice, you will not be able to really have meaningful of the answer and link the answer to something. So, string.format, the textbook offer you a lot of variations. It's good to go and try all of them. Yes, I can see the solution. I can see the difference when I have dot, when I don't have dot, when I have 1 or I have 2 or I have 3. But if I didn't practice this, I don't think I will remember. Any other question before we proceed? As you can see here, we did not rely on the models to create a class for us. We can create our own class, and then we work with that class called circle, and we give radius as an attribute for this class, and we create a method inside this class to calculate the area for us. So you can demonstrate all of this by going to the model here. As you can see, I don't have any class. In this case, I rely on the view and the controls to do all this for me. I don't have really a separate concept. I use the model, but I'm not using it as a separate or a solid model. For example, in the D1, you have a BMI class, and you have the view, and you have the control to link between them. So you can right-click here and ask for a new class. In this case, you are creating a class of circle. So as you can see, we use the name convention, and this is a public class, and then I will ask, okay, this is my class, this is my model. So this is my class. What I'm gonna do today is to present for you, then we go to the slide, there is a theory in the slide. Before I discuss the theory, I would like to highlight this one for you. So, you see we create this computer area without using any class. Now, if I would say a class called circle, what kind of attribute I need? You might say I need the center of the class, of the circle, and I need the radius for the circle, then it will be a completely identified circle. I know where this circle is located, and I know where this circle is gonna compute. So you add the attribute, X and Y, or you would like, you can, and then you can double and radius. You define these attributes. So any object of this class is gonna have 2, 3 attributes, X and Y and R. Now, let me just give you to make sure that everybody understands what is the object-oriented programming. Let's say you have the factory where this factory is gonna create chairs. This is the product. This is what they are, businesses. It's creating chairs, manufacture the chairs. So how do they manufacture the chairs? First, you're going to go to the end user and pick up the specification. What's the requirement? The chairs that we are using right now is different from this chair. Is that right? It has some specification is different. This is a lecture chair with the connect level, there is a metal and all of this. It's a heavy duty because many students going around, but this is might be not concerned about that. So we go to collect specifications. Based on this specification, we go to the engineers or whatever is a programmer, designer, whatever. He's gonna draw some maps. He's gonna put some specification on a piece of paper. Based on this specification, once it's approved, we're going to send it to the production line. At the end of the production line, we're going to have the chair. Exactly this is how we're going to do in the program on Java. You're going to have the specifications based on the user requirement, and based on the specification, we're going to create what we call a class, which is a template. And then after that, you are using this class to create an object. Each object has his own attribute. All the chair have the same weight? Maybe. In reality, nothing is real. So you will have different weight, a different ID. Chairs are different ID, different color, maybe the same color. There's some specification you can catch it from the class. Here we have some called static features. Without seeing any object from the chair class, I can look at the diagram of the chair. I can know what the color of that chair. Based on the specification, I'm going to create a black chair. So this is a static. But in reality, might have a little bit gray because the color was not mixed in the production line, and then I will say, oh, this is a defective chair, malfunction, then I will throw it out. I will create another one. So in reality, I will have the area, but I cannot get the weight based on the diagram. To be able to get the weight for the chair, I have to see the physical object. Is that right? The same thing. The class does not have a space or a size on the value. When you create the object, you reserve a space. So with this kind of similarity between these two examples, keep this in your mind. Whenever you come across creating a class like this, and then you create an object from class. And sometimes we're going to come across some classes we create, and we don't need anyone to create an object from it, like a math class. This is a class, no one can create an object from it. Now, to be able to create an object, let me just go back here, and let me just define a method, or, okay, let me forget about the method here, and go back here, and create a new class called test circle. This is not a class that is going to test the circle using a JUnit test, but is just to highlight the concept. I will define a main in this class. Then I will say circle, okay, and I will say a circle equal a new circle. Then I will ask system.out.print Can anyone tell me what exactly I did here in this code? In this, I just create a class with 3 attributes. In this one, I try to test my class is working or not. So I say I'm going to define a variable called a circle with a type of class, and then I create a new. New is a keyword, where it allows us to create a new object. So by doing this, we create a new object from this class, and I'm trying to print it out. What do you think the output? If you look here, I didn't specify the quantifiers for these attributes. So by not specifying these quantifier public or private, I assume the access will be package access. So whenever you have a class within the same package can access these variables. Let me just make it a private. And there's another private. Okay? Now, these attributes are private. You cannot access them from outside. That means we cannot create an object, or we're going to have the object. Let us try to run this. Actually, the object will be created. Java will already have an implicit constructor for us, no argument constructor for us. I'm going to cover this in theory, but I want to show you in the practice before. Now, in this, as you can see, when I ask to print the circle, might be someone say, I will print the center of the circle on the radius of the circle. But actually, Java will not be printing that. Java will print actually some random reference where this A class, a circle, is stored in the memory. And what the type of it is all this big string related where is stored in the file. I can create a method inside this to print. I will call it toString. Now, if I want to create a constructor for this, a constructor will be responsible for creating the object for us from this class. I need to make sure what kind of constructor I need. And as you can see, Java already insert someone for us, even we don't have any constructors. Constructor are special methods, or some people, they avoid using name method to it. It's a constructor. Constructor, whenever you come to your mind, constructor is something responsible for creating the object. I can rely on this, I say generate, I need a constructors, and will include all the attributes, say yes. So this constructor will include only X, but if I would like to have a constructors that include all the attributes, then I will say I need all the attribute to be. So I cannot create the object without using all this. Let me just go back what the effect of adding this constructor on this test. You can see here, there is a red. I cannot do this. I cannot create the object right now. You see the difference? When I create the class without any constructors, I was able to do this, create an object with no argument constructor. I rely on Java experts because they understand I create a class without a constructor, they already inject the implicit constructor for me. But once I decide that I cannot create an object from my class, I need 3 arguments. I need X and Y and R to be able to create this object. Then I cannot do this. Now, if I try to run this, I will not be able to run it. There's a problem. See? Compilation Java code problem. How I can solve this problem? I have to provide X and Y. As you can see, I provide the argument as an int, but the Java will make a promoted for me and will make them a double. Let me just go back to the slide right now. I hope this, okay? And if you want to print something meaningful, you override toString method. You can have another method here, generate getter method that can get X, method can get Y, method can set X, set Y, because these are private. You cannot access them from outside. You can access them through a method that you provide. Okay, so let us go back here. Okay, this is the demonstration of the calculate the area. You have the text view and then input and the button and you calculate. And this is the XML design. You have text view and then edit text and the buttons and text view to display the result. You have the Java code. This is the main Java code, the main activity class. This is the help method that allow us to get the text content, set the text content of the text view, and also get the content of edit text. I recommend all of you in your apps to use help methods. It will make your code more readable. Now, this is the method is called compute area. It's responsible to compute the area and also get the value from the user interface items and then display the result. This is an example of runs. So set the text on the text view. This is I put it in the separate slide to highlight that we can grab the ID and then we can set the text to view. Yes.
Why are we casting views to type edit text or text view?
Why? The question is for you. You are working with user interface items. What the type of it? You have user interface items. What's the question you can ask me? What type of user interface item I'm working with? Text view, edit text, buttons. So you have to cast it. As a user Java programmer, you have to know what the type of text view you are working with. Here, we are working with edit text, and we would like to get the content of edit text. So we have the ID, we cast the ID to view. The view is the parent for all the user interface items. So you can do the view, all the user interface items, you can cast it to view. Then the next line, I want to be more specific, I'm working with edit text. Yes. This is another, sometimes you would like to clear the content of edit text. So after you grab the content of edit text, you would like to clear the content, you can use the set text and you send empty string to the edit text. Okay, this is the push buttons. Let me just go back. Okay, so this is where you click the buttons and you change the background of it and the text. So you can see it's randomly changing the color and give you the percentage of red, green, and blue of this. In terms of the code, this is the method. It's responsible to change the color of the background. You ask math.random. Random will generate a random number between 0 and 1 where 1 is excluded. And then you multiply this by 256. And then you cast the result to int. Then you make sure you have int number. And you do this for the red and green and blue. And then you do the percentage of each one of them because you need to display the percentage on the text view. And as you can see, I don't use the help method here. I do find view ID and they give the ID and then they cast the ID directly to the text view. Then I set the string and here I display the background color. To be able to display the background as red, green, blue, you need a color object. So I'm using with a color object, color class, dot red, green, blue, and I provide a red and green and blue numbers that I used here, generated randomly. Then I use p.set background color, which is one of the attributes of the buttons. Any question? I will do it. It's here.
So in the code, so you declare it in red and in 256 and red. Why do you declare that in like the int in the brackets?
This is a casting. I'm doing casting because I need, whenever I need to create a color object, you see this line, int c is equal to color.rgp. This is a constructor to create and retain for me a color object. A color object that I'm gonna use, I need red, green, and blue as an int data type. So math will retain double times 256, that's an int, will be promoted to a double. Then I have a double. Double is not working with the color. I have to make it as an integer. So I do it between the parentheses and then I cast it manually to an int data type. Okay? So this is the way I've generated the randoms, and this is the way of I creating the color objects. and then I set the background of the curve. Any question? Okay, now we're gonna start the main thing, and most of the discussion we already go over on that example where we create a circle as a class, and we highlight why we need an object-oriented programming. So object is a concept where you integrate the state, some attributes, and some behavior. When we say a behavior, we say a method that works with some attribute. And you can see, when we create the circle, we define x and y and r. These are called the state of the circle. For each object of the circle at a time, we will have different x, different y, and different r. So this is the state. This circle is located at origin, this circle located at 1 and 2, this circle with the radius 2, this circle with radius 5. So the state of the circle is different. Now, there is a method or a behavior for this class about computing the area of the circle. This is one of the behaviors that is linked to this objects. So you put the state and the behavior in one. The concept is called encapsulation, and we're gonna come across that. So the class is work as a template or a common structures. We will use these common structures to build an object. Like the chair examples, you go to the factory, the people on the design department, they draw all the specification on a piece of paper. They give this piece of paper to the production line, they start seeing chairs coming out at the end of the production line. If the chairs meet the specification, that's good, then this is an object from this specification, which is the class. The same thing you're gonna do in your program. You create an object called BMI. BMI model is an object class specification, then you start creating the object from this BMI. Okay, so each object is created as an instance of a particular class. You cannot have an object without linking this object to a class. Okay, it's the same as you cannot define a variable in your Java code without saying what the data type of this variable. I want x to be an int. I want x to be a double. So you need to tell us what is the data type of your variable. The same thing. You want to create an object, you have to tell us which class is created from. A constructor is a special method. I'm gonna call it special method, but some people, they avoid call it even a method. So a constructor is a special way or a special, you specify in your Java code how my object should be created. As you see on the previous slide, when I go to the circuit, I didn't provide any constructors. Then I will let the Java lead the way of creating an object of the circle. Then I create a new circle with empty parentheses. And I was able to create an object. But once I decide I cannot create a circle without providing x and y and r, Java said, okay, we cannot create an object without having these three attributes, x, y, and r. So the constructor is a special method that acts as a factory of making a new instance. And to make this method valid or do the job, you have to use a new keyword. New is a keyword that will invoke the constructors. This is an example of a student class. And as you can see, we provide some comments and documentation about this class. What is the purpose of this class? You as a Java programmer, it's good to have a documentation about what you are doing. Okay? And then you see public class students. So the header of the class is a public. Everybody can access this class. A student is the name, a quant identifiers that I define in my Java code related to this. So I'm gonna later on use a student as a capital. So to create an object of a student. As you can see, we have two attributes, or what they call it, instance variables. Why they call it instance variable? Because this is linked to an object. Whenever I create a student object, I will have different name, different ID. It's the same thing. You have the specification for the chairs and you send it to the production. Each chair for sure will have different weight. Unless if they are perfect manufacturing process, all of them will have the same weight. Okay? I know in reality they will be a different. There will be a tolerance. They say, okay, if the weight is less or greater than this amount of fraction, it's okay, it's acceptable. Otherwise, we're gonna redo the process. So each object you create from the student class will have name and ID different. So that's why they call it instance variables. Now, if you have some attributes that link to the diagram, let's say the color of the chairs is a black. All the objects they're gonna create on today, they will have a black chairs. So this color is called class variables and is defined as a static. So all the objects they're gonna share the same colors. We call it a class variables. So make sure you difference between instance variable and the class variable. And we're gonna highlight this later on. So this is our kind of attributes for this class. Then we have a constructors for this class, a student, and we provide a string name and ID, and we take the name and ID and put them together to create a new object. So by providing the constructor, we tell the Java, please, you cannot create a student without name and ID. So if the user gonna use our class, he will not be able to create an object without providing name and ID. Then we have a get method for the name and get method for the ID. The get name will retain a string because the name of attribute is a name, student name is string data type, so we'll have it retained in this method. And also int as a data type for the ID, we retain the student ID in the get ID. This is toString. We discussed this. If someone would like to print the student object, I would like to print the student. You saw that when we create a circle, we try to print it something meaningless for us. With where is located, what is the class, with some random number about the address where it's stored in the memory. But if you would like to print the student object in a meaningful, you should override toString value. And Java Android Studio offer this for you by right-click and ask for toString value. It will give you a template. You can revise it. You can change it as you wish. Okay. So once we define a student class, we can then use the constructor to create an object from that class. This is an example of using the class. Student, stda, this is the name of the variable I use, and then a new student. I provide the name and ID for the student. Then I create a student P where I give another name and another ID. Any question? Okay. A method toString is very useful to represent the object. So I would like to represent the object to the end user. Once you create the student object, you would like to print it. It's a representation. So to override this method. And whenever we are using the object with a print or print line, this method will be called automatically. Okay? Even if you're not explicitly called toString, if you are using the object with as an argument for a print or a print line, it will call this method automatically for us. So you can see here, I define two student objects, student A and student B, and then I asked to print them out. I didn't call student A toString. I didn't call this method explicitly. Java will understand you are trying to represent this object, printing this object using a print line or a print. It will call the toString. So we're going to see if toString is overridden, yes, and we're going to see the representation. As you can see, we're going to print the student name, then concatenate it with a parentheses, a number sign, then student ID, then close the parentheses, and retain this as a string. So this is the result. Okay? Any question? Okay, all of you already create what you call a PMI class on D1. You have attribute, private, double and white and height, and you calculate the constructor here. This is the constructors you create. You cannot create a BMI model without the weight and height. You receive them as a string, then you convert the string to double by doing double dot bars, and then you get a BMI. As you can see, you calculate the BMI by weight divided by height square, and then you cast this as a string. Yes?
What's the least probably the least?
Yeah, we're going to cover this later on, but I can quickly answer you. This is a reference to the object is being constructed right now. So this is a name of a variable. Java expert already make it available for us. You are trying to create a BMI model right now. You need a way, still not complete right now. You need a way to reference to this object while you are creating it. This is the way to point to the object is being constructed right now. So this is pointing to the object is being constructed right now. This is one of the features of Java is provided for you where you can reverse to the same object that you are working with. So this is a capability where we can say inside the constructor, you construct the object of BMI model. This dot that runs to the same object is being constructed right now. This dot weight, and then you assign the weight. This dot height, you assign the height. Okay? Any other question? Okay. This is where we are printing a BMI. As you can see, I would like to print a BMI model here. I create a BMI model and I would like to print it out. What do you think the result? This is the result. I don't have toString method is overwritten on the BMI model. As we explained earlier, we have to go to the class, check if we have toString method or not. If we don't have string, then we rely on printing something. Maybe this 67732.7p6 is related to the memory in my machine, okay, at these locations. So you have object there. Yes? Questions? Okay. So then a class is a way where you can create your own data type inside Java. I create my own data type just right now. I create a student as a data type and then start defining a variable and creating an object from that data type. Okay? And this is a class where I create an address as an object, okay, class, and then I start creating address objects. As you can see, we have different attributes assigned to this class. Now, objects represent a multiple piece of information that you group together. Now, try to think of any kind of things that you are work with in real life. For example, let's say laptops. We can create a class, represent a laptop, and then we add some attribute to this class. Okay? What's type of attribute? What's the make, the model, the RAMs, the size, the CPU, frequency, all of these as an attribute, okay? So objects represent multiple pieces of information. You group them all together and you start work with them in your Java code. A primitive data types, int, float, char, double, all these are a single piece of information. It's not an object. That's why we have to make sure we make a difference, a clear difference between a primitive data type, which is represent a simple piece of information, and an object, which is a bundle of data together. Okay? And you can have an object inside another object. That's a good features. You can define an object inside another object. I can have a classroom as an object. Inside it, I have chairs, tables, machines, electronics, all these as a class and object inside another object. objects. This is an example whenever you want to define, I can say address, and then I give a variable name or an identifiers, ADR, and semicolons. I say I want a reference. I didn't create the object right now. By executing the first sentence, I don't create the object. The only thing I tell the Java compiler, ADR is a reference of a type address. If I want to create an object, I have to use the magic keyword, which is a new keyword, a new address. As you can see, I don't provide any parent argument. Then I will rely on non-argument constructors to create the object for me. Then I start saying ADR dot operations. I will start access the content of that object. What do the object contains? The name, street numbers, street name, city, province, postal code, and then I don't have the capability to print the address. I will start accessing the items inside this and print them individually. Why I was able to do this? If you look back to the class that I defined, I say public string name. So everybody can access the name using the reference. So ADR is a reference to an object of address. Dot, I will be able to start accessing the content of that object. And one of the content that I can access using this is a name. So I can access the name and assign the value directly without get method or set method, without set method actually. I just can access the name and assign the name. I can also use the name on the print statement. As you can see the difference here, the street number is an int, which is represent a piece of information. So you can see it's stored directly on the object 1022. Okay? While the other piece of information are another object. A string is an object at a time where you're going to store a reference where this object is stored. Okay? An overview is an object contains the variables and as well as the method, which is the behavior. The variable and the method are called a member of the class. And if you go to the reference through all these literatures and the Java programming teachings courses, the variable inside the object, sometimes they call it a fields, data, attribute, instance, variables. So you have different names. All these names are referring to the same thing. So if you go to some cross-reference or some other tutorials, they might call it a data. Some people, they call it a field. Some people call it attribute. Some people call it an instance variable to make sure this is related to the object that you create. Okay. So in general, when you define the variable or attribute of the class, you are using a private. So you cannot see this attribute outside the class. And then you use the get method and set method to set these attributes or to get these attributes. The constructor I use to initialize the field whenever you create the objects. So whenever you create the object, a new circle, you give x, y, which is the center of the circle, and you give the radius for that circle. This is an example as we discussed, is a circles, x and y with r. So these are data, and we call it instance variable because these are related to each object we create. Each object will have different. This is how we calculate the circumference of the circle and also how we create the area. These are the methods, represent the behaviors. Whenever I create the circle, I can do the calculation for area and circumference for these circles. And the implementation of this method is the body of this method. Now, data abstractions by declaring the class is like an abstract. As I mentioned, when I say circle, a circle, circle, B circle, A circle and P circle are name of the variables. What's their reference for a data type of a class circle? Right now, I don't have an object in my hand. So you can think that these are pointing to null. A circle, P circle are currently pointing to null because I don't create an object for these. The only thing I let Java code or that Java compiler knows that I only have a reference of type circles in my code. I'm going to use it, I'm not going to use it, I don't know. Then if I left this without any use, there will be a garbage collector and mechanism to get rid of it. Okay? If I use a new keyword, a circle equal a new circle, in this case, I will create an actual object and I will reserve some space on the memory. And the attribute will be X and Y and R. And each object will have different attributes. So a class is a user-defined data type that represents some attributes and also contains some methods. An instance of the class is an object that you create from that class. Declaring the class, you need to make a modifiers, class keywords, then you have to give a class name. You will give a list of attributes that you declare, a constructors, and also you give a declaration of the method. This is an example where you define a public class counters, and you have a private int value, and you have a constructors. You already provide a constructor, no argument constructor, that initialize this dot value is equal to 0. So you initialize the counter to 0, and also you start increment the counter and get the value of the counter. As you can see, increment the counter will only work with this dot value plus plus, which is increment the counter by 1 and will retain void to the user. So just work with the state of the counter. So what's the state of the counter is the value for that counter. What's the value for that counter? You can get the value by using get value. Will retain the state of the counters. To define the attribute, you have to provide a modifiers, types, then the name of attribute, and initialize these attributes. So as you can see, we have a class rectangles, and we provide attributes width and height, and we have initialized them as 0, 0. Both of them as a private, and we have a constructors where we create a rectangle and width and height, and we initialize them. Yes?
Oh, I was actually wondering, why do we use this if you only have three different variable ones?
Using of this is very powerful things, because sometimes the variables inside your method conflict with the name of the attributes. To remove this conflict, for example, you cannot see this on this example, but I can told you if public rectangle int width comma int height, the priority for the input argument override the priority for the attributes. To make sure the distinction is clear in terms of what you are referring to, you have to use this. It will be highlighted in the next slides, okay? So these are the attributes and the constructor. Now I'm going to come to highlight this concept, which is the static class, or some people they call it utility class. Is a static class, it has a features and also it has a method, but you cannot create object from these. Did you come across some of these? Yes, we did. We come across the math class. Math is a static class, we cannot create object from that. Okay, so therefore we cannot create object, and normally, if you want to create a class to prevent an end user from creating an object, you provide a constructors. You write a constructor, and this is an empty constructor, and the modifier for this constructor is a private. So no one can access this constructor. Once it's a private constructor and empty constructor, no one can access it, no one can create an object from your class. This is an example for a static class, rectangle, and as you can see, we don't have any attributes, and this static methods, get area and get circumference for the rectangle needs input argument to work. I cannot calculate the area if I don't receive the width and the height. I cannot calculate the circumference if I don't have the width and the height. So I need this argument because this is a static class, okay? And I cannot work with methods without input arguments. To be able to use this method, we don't need an object even to call this method. The name of the class dot, then we call the name of the method. This is a static method, public static int get area. So you use the name of the class dot and you give the name of the method. You don't need to create an object to use the static method. So the static method and static variable of the class, you can use them without object. And some people, they use the static variable as class variable because you can access these from the class method. You can access this method without creating the objects. So these are static method, and we can use the name of the class to access this method. Now, non-static class, this is the most of the time we're going to create what we call non-static class, where we're going to use these classes to create objects. So we're going to have a constructor that gonna construct this object. And each object that you create will have his own copy of non-static variables. Now, back to the example of the chairs. Each chair you create will have his own weight, okay? In the theory, practical, no chairs will have the same weight if you measure them. But all of them will have the same colors. So the color is a static variable, it's per class. But the weight is an instance, non-static. It will bear objects. So the same thing. You'll have all the students have the same name? No. Students will have different names. So that's why the name of the students is non-static variable, and each object you create from the class of a student will have his own copy of the non-static variables. Then we have objects and object represented by the state, and you can think about these equations. Object is equal to a state plus a behavior. So whenever you think about an object, if you not satisfy, for example, I don't have something on my Java code that's represented by state and behaviors, then I might go over a static class. I don't need to create an object because I don't need a state. But if you are gonna come across creating an object from a class, then you will have to represent this as a static state and behaviors. This will represent actually the real-time situation. As we mentioned, you are working with things around you, like cars. You go to the car, cars contains many objects. So you have an object inside that object, many objects, and each object will have different state. So this kind of thinking of object-oriented is already adopted by Java, will allow us to program things in terms of classes and objects all over your code. To be able to call any method, you cannot create a method without creating the class. Even if someone say, I don't need to create an object from that class, Java offers you an option to create a static class where you can provide a behavior method for that. For example, the math. I cannot create an object from math, but I have some certain behavior that related to the math. For example, I define a constant y. I can calculate the sine, cosine, tan. All these are calculation, can find square root. I can do the power. All these kind of behavior, but I don't need to have an object to do these behaviors. Okay? This is an example, a full example for non-static class for a rectangles. You have width and height for the rectangle, and you have the constructors to create the objects. And as you can see, the difference between the get method here, get area, you need to work with the state of the object. This dot width, this dot height. While on the previous one, I don't have any this dot because I don't have any state. This is a static method. I will receive an input argument with the width and height, and I calculate the value. And then I calculate the simplifiers. And you can see here the way of working with this class. I create the object first. I initialize the width and the height of the object using the constructors, because the constructor is responsible for creating the objects and initializing the state of the objects in the proper way. And then after that, I can say r dot get area, r dot get simplifiers. R is the name of variable of a type rectangle. I didn't use rectangle dot, while on the static method I use rectangle dot. And even these are not static method. Get area is not a static method, it's an instance method. It's a method that linked to the objects. Okay? I can use get area here after I define the object, while on the static class, I don't need an object at all. I use rectangle dot. Rectangle is the name of the class. So this, we call it a class method. In this is an instance method. Get area, I need an object to be able to define, to use this method. Okay? Any question? Okay, so you will have classes, and these are example of class. String is a class created by Java expert. You can see date, integers, Arabian class. Okay, when you implement class, you need to choose the appropriate fields and the behaviors. Let's say I would like you to describe this table for me. What kind of things you are using to describe this table? The color. Any other attributes? The height, number of columns, this. Then these attributes, whenever you come across any problem and you would like to approach this in Java code, you think about objects. Then I will create a class table, and this class will contain some attributes, colors, area. Maybe this, I will be able to create an object of a round shape table. Okay? Then I will make attributes, the shape of the table. The number of columns, 3 columns, 2 columns, okay? Or 4 columns, okay? The height of these columns. Are the columns are squares or cylinders, as you can see, okay? So all these kind of things, describing an object that you have, then you will start creating class. In the simple example I come across over, which is a student class, I describe a student in York University by just give a name and ID. And might be now, if we open the discussion, we will end up with have a huge list of attributes that can describe these students. It's a full-time student, a part-time student, it's an international student or a Canadian student. All these kind of things is make a difference in calculating the tuition fees, even, yes? So I will be interested to know more about the objects so I can design it correctly. Okay, so this is an example. If I didn't complete it today, you can go over it. If you have any question, let me know. This is a very example. Let's say I'm going to take just a point in 2 dimension. I ask you, describe a point in 2 dimension. What do you need to describe a point in 2 dimension? Yes? X and Y value. That's all what I need. Okay? Then we have X coordinate, Y coordinates. So this is my class. Simple point 2, I define public float X, public float Y. So these are 2 attributes described. I didn't provide any constructors. By doing this, if I ask you, I can create an object of this class, true or false. Given this class definition, end user can create an object. Yes. Why? What? It's not static, that's right. But because Java expert provide an implicit constructor for us. If you as a programmer forget to provide a constructor, Java will add one for you free of charge. You have to be careful. Okay, you have to be careful. Okay, so this is a public, client can use it, even the attribute are public, you can use it. So the client of this class, you can use it inside the main and you can create an object. Now, I can, as you can see, I can create a simple point two, an empty argument constructor. This is a free of charge constructor provided by Java expert for me. I use it, then I say p.x, I assign the value, p.y, I assign the value, I print them out. Is this code is working? Do we have any mistake here? It will work. No, because I define the class without any constructors. So I rely on the Java free of charge constructor, which is now argument constructors. Keep this in your mind. Okay, this will work and will print the value, no problem. Then someone say, as you mentioned, I should be able manually to set X and Y. How I can do that? I will not have a capability when I create the object to do that. So, as you can see, sorry, to the back of that slide, so initializing the coordinate of that point, we have to do manually to put X and Y. As you can see here, I have to go to X and go to Y, and both are defined as a public, so everyone can access them from outside. And as you can see, I define another point called the Q, a new simple point, and I assign Q.x, Q.y, the same values as Q.p.x, P.y. Then I ask the questions. Is P.equals Q? And by the way, equals is a one method that Java expert give it to you free of charge, unless if you decide to override this method. So, by simply defining P and Q and asking P dot equals Q, what do you think the output? Are these methods, are these points are equal? For me and you, they are equal. For Java, they are not equal because these are two objects are located on different address on the memory. So different address on the memory will end up these are two not equal. Unless if we go explicitly and override a method called equals in our class. Okay? Again, the concept of encapsulation here is the simple point two has some features, and we use these features to represent the simple point two. We have a constructors that create, we can use the constructor to create and set value for this field of a simple point two whenever we create it. Okay, and also we can have the string representation. So the concept of encapsulation is about, we already highlight this, is bundling the features with the behavior together. Is like creating a protective bubbles around your objects. Nobody can access my object only through the method that I define. No one can change the state of the object only using the method that I define. What is the state of my object? I already represent the state of object by the attributes. Is whenever you create, think about this kind of encapsulations and the protective bubbles around your objects. A constructor is a very powerful way of creating. The purpose of it is to create and initialize the object in a proper state, and always initialize the value of non-statics. So must have the same name as the name of the class, and never retain a value, not even void. So even the constructor has no retained value. The name of the constructor is the same. Here where I mentioned the constructor is not a method, because normally the method has a retain type and has void as a retain type if you don't like to retain anything. So that's why from this point we see that the constructor is not a method, because a constructor has the name equal to the name of the class, and we have no retain type. Even void, we cannot use it with the constructors. That's why I told you at the beginning, some people even they are afraid to call it a method, because whenever you say a constructor is a method, then you have a retain type, and if not retaining anything, then you have to say it's void. But constructor retain nothing, no void even. And we can have 0 or more parameter with the constructors. And implicit constructor, you already saw this. Constructors is a no, like this class, public class, no constructor. Just an empty braces. I can use this and I create an object. Java allow me to do this. So just simply I define public class, no constructor, I empty braces, and then I go and try to create an object from this one. I can do that because Java give me a capability to do that. Now, if I define the constructor should have some modifiers. There's no retain type. The name of the constructor is the name of the class, and also we have some arguments. This is an example where I have a date class and I have a constructor for the date by providing the year and the month and the day. Default constructor, they call it a default constructor, has a name which is the constructor with 0 parameters. So if you see a constructor with 0 parameter, the name of it is a default constructor. Normally, the default constructor is used to initialize the state of the object in a proper state based on the programmer requirement. For example, here we have a simple point 2, we have the default constructors. Even if the constructor has no argument, what's the difference between this one and we don't provide any constructor on the previous one? So this, by telling the Java, if whenever you create a simple point 2, you should initialize x and y to the origin. Okay? So inside this, we use this. This is a reference to the object is currently being initialized. If you have any doubt about this, this is a reference provided by the Java to help us to initialize the variable object that we create. So all the attribute of the object that you are currently creating, you can access this by this dot. A default constructor take no argument. Default constructor body sometimes being empty. So for example, this is a default constructor for a date class that we create, and we could provide an empty body. A constructor without argument, you can have a constructor. This is an example, no argument constructor. I define a class, no argument constructor with a public, no argument constructor. The name of the constructor is the same as the name of the class. And we can use this to create an object. Now, constructor with argument, this is the most of the time you're going to create a constructor or create an object with some arguments, and you need to initialize the object that you create based on some state. So here is I create a constructor with argument. I have the final string argument 1, final string argument 2, then I provide the body of the constructor. So we cannot create object from this class called constructor with argument without providing both arguments. Java will prevent us from, as you already saw that when we define a circle as a class and we didn't provide any constructor, we were able to create a circle without providing x and y and r. But once I define a constructor where this constructor takes 3 arguments, x, y, and r, then Java will stop me defining any objects. A custom constructors, a constructor, sometimes the class contains multiple constructors. Based on the signature of constructor, we know which constructor we're going to call. Let us see the example. Here is the example. We have simple point 2, and we're going to have x and y provided as an argument. As you can see, this is the way where it's highlighted that this is the power of using this. X and y in the argument is identical name of the attributes. We have the attribute for this simple point 2 class called x and y. So inside the method, I need to make a distinction between what I'm assigning to. This dot x equal x, then I will take the input argument x and assign it to the attribute of the class x. Now, the input argument has high priority than the attribute. It's override. So inside the body of the method, when I just say x, it will understand as an input argument. It will not understand this is an attribute. That's why it's good to use this dot x to make sure that I'm calling the state of the object. So this dot x is the field name x, and this is pointing to that x. X is the parameters. So you need to make sure you have a distinction. In this example is very powerful example to show the difference and the power of using this. Now, whenever I define the object, I told you, if I say simple point to P and semicolon, I don't reserve any memory. But if I say simple point to P equal a new simple point 2 and then I give -1 and 1.5, then the client will have P, a reference for a simple point 2, then it will go allocate the memory for X and Y, and in this case X and Y is a float, then I will calculate and find a proper amount of RAMs for this, and I will assign X and Y for them, and then I will assign the value -1 and 1.5. And this is pointing to that object is being constructed at 600. 600 is where the object is located in the memory. Then I will call this dot X and assign X and Y. Any question? So in this slide, you can see you reserve the memory once you are using a new keyword. So this, in our constructor, this to point to the attributes. In case if you have the input arguments of the method has the same name as the attributes. Okay. A custom constructor, back to the discussions. So if you would like to add a simple point to X and Y, so this code, we could remove the reductions in this code. Now we can say, as you can see, I create point, then in the next step, I initialize it. I can use the initialize it inside the constructor itself. I can remove all this code, and now I can use the constructors. I can use the constructor -1 and 1.5. So now, when I create the point, I initialize this point directly. The same thing, I can use the initializing from other object state. A copy constructor. This is one of the powerful constructor that you can use. You have already created an object, and now you would like to create another object, but this object that you are creating right now is identical to the object that you created already before in your program. You start a program, you create a point, then later on after few line of code, you would like create the same point, but you need to assign it to a different reference. So you can use the copy constructor where you copy from one object to another. This is the style of a copy constructor. So you are saying public simple point to, and take a one argument is a simple point to others, which is the other point that you try to copy. And in this case, they say this dot x equal other dot x, and this dot y equal other dot y. So you can take an existing object and create another object by using a copy constructors. And let us see how the copy constructor can affect our code and simplify it. In the original version of the code, we have to create a point Q, a new point, simple point 2, and we have to give X and Y explicitly from P. Now I don't need to do that. I assign P, and then the copy constructors can go and take the state of X and state of Y and assign it to the X and Y for Q. Okay? So, as you can see, a class can have many constructors, and each constructor has different signatures. avoid duplication in your code. Whenever you try to do ads or any other programming exercise, try to avoid a duplication in your class. Sometimes we need to use a chain of constructors, and we will see that here. So a chain of constructor is a constructor gonna call another constructors. So you make a creation of your object in your class as a single point. Even if you are providing different constructor for the end user to create an object with different version, but you are creating things on a single point. Let us see how the chain of constructor based on the example. As you say, see, we provide in a simple point 2 3 constructors. Simple point 2 with no argument, we initialize 0 and 0, and you can see we say this and we provide 0 and 0. By doing this, we're going to call simple point 2 with argument x and y. So we're going to call this constructor. So the no argument constructor going to call a constructor with 2 arguments. And also look at the copy constructors. The copy constructor going to receive other objects, then we're going to take x and y from other object and send it to the x and y constructor. So this style, we call it a chain of constructors, and you make sure that the creation of object is a single point. So I can go to the middle constructor and modify it, and all the rest, it will follow the same modifications. I don't need to go to each type. I create the constructors and modify it individually. Now, 2 variables referring to the same object. In this way, I create day 1 and day 2, date 1, date 2, and both of my date class. And in the first one, I use a new date, and I give 26 and 2000. So, date 2, I say equal date 1. By doing this equal sign, I am creating a new object. I'm using copy constructors. I'm not using copy constructor at all, because to be able to use the constructor, I need to use the magic keyword. What is the magic keyword? New. I don't use a new. So what I'm doing here, actually, I'm making 2, date 1 and date 2, pointing to the same object, which is a very serious problem in the coding. In the object-oriented, you have to understand, whenever you define date 1, you create an object. Date 1 is containing the address where the object is located inside the memory. And when I say date 2 is equal to date 1, I just make a sign to the addresses. Both have the same address, so both are pointing to the same objects. So I can modify the state of date 1 using date 2 variables. Okay? Interesting fact about the constructor. Constructor can call each other using a special keyword, which is this, as you saw in the previous example. It's considered a good practice to have a chain of constructors that will reduce the code, okay, lines. And for example, if you are deciding to create a constructors where you initialize 2 attributes or 2 variables, but in this type you want to initialize only 1, still you can use the 2 variable constructor by using this dot, and you provide the argument 1, and you provide the second argument as null. So even if you are creating a constructors with 1 argument and you would like to call a constructor with 2 arguments, you can do that by using this argument 1 command null. This reference is used to resolve the ambiguity between the instance variable, which is the attribute of the class, and the parameters of the variable. To pass the objects to the current object as a parameter, you can use this as a reference where you pass the object is being constructed. Okay? And this is an example for a class where I define my date, day, month, and year, and I have the constructors, and I have a copy constructors, and I have some methods where it's create next date. Okay? So to be able to create, as you can see, create next date, it will retain an object of type my date. Okay, any question? Okay, so I encourage all of you to read the slide from the method and so on. We're gonna start this from next lecture. We're gonna cover the methods and some other information, then we're gonna go some review questions.